So, good morning student. Come back to the topic where we have left, that is the block diagram of 8257 as well as the pin diagram of 8257. There is the only difference in block. If the question will be asked that draw the block diagram, then you have to draw this left one diagram over there and you have to explain all the parts of this diagram. Otherwise, if the pin diagram has been asked, then you have to explain this diagram. In the pin diagram you have to explain the pins of 8257. So in block diagram you have to draw this diagram and you have to explain each block. Here this is very simple diagram you have done in CSA also. These are the 4 channels. 4 channel means channel 0, channel 1, channel 2, channel 3. Vice versa, if you have done 8257 pin diagram, the same things are you have to explain in block diagram. If you have done block diagram, the same pins are there in 8257. So the only thing how to present the diagram, the only difference is here. Pins are same. So here these are the 4 channels and data request signals are DRQ0, data request 0, data request 1, data request 2, data request 3. So same data acknowledgement, same data acknowledgement 0, 1, 2, 3. And when we are writing these signals, so these are the pins which we can show DAC 0, DAC 1, DAC 2, DAC 3. So these are the 4 DAC acknowledgements sent by the DMA to the input output devices, and same these are the 4 requests which are input output devices sends to DMA controller. So 4 into 4, 8 pins we have covered. So GND is the ground pin, means earthing. This is the signal earth to the ground, and the same way we have VCC, that is plus 5 volt DC supply. All these pins we have done. So now come to the block diagram. What else is there? There is one priority resolver, one control unit, one read-write logic, one data bus. Data bus is D0 to D7 that is available to transfer the data, and the same pins are also there. D0 to D7 pins are available to transfer the data. Other pins are which are available here, that is CS. CS is chip select pin. Chip select is used because there are 2 modes in DMA. One is master mode, one is slave mode. So chip select, when it goes high, it means we have selected the slave mode, and when it goes low, it means we have selected the master mode. So these are the 2 modes which I'll send you notes of the master and slave modes to you after this PPT. So these are the pins and block diagram of DMA controller. In DMA you have to learn these 2 points. These are very important because we have 2 registers in DMA. One is DMA address register, another one is the byte count register or simple count register. In DMA address register, what does this address register holds? It is a 16-bit address register. This register is loaded with the address of the first memory location to be accessed. And what is byte count? It is also of 16-bit. Its 14 LSB shows what data has to be transferred, and the 2 MSB shows which operation has to be done. Means either we want to do write operation on memory or we want to do some read operation in memory. So this is the control word which control register count register, which has been shown from B0 to B15, 16-bit registers. 14-bit are used for what exactly? Data. This is the data. These 14 bits are the data, and these 2 bits they are used to show which operation has to be performed. If the value of these 2 bits is 00, then verify transfer, 01 write transfer, 10 read transfer, and 11 is illegal. So these are the one by one explanation of the blocks. In DMA channel we have done, there are the 4 channels, means at the same time 4 input output devices can transfer the data, and these are the DR0 to DRQ3, means these are the data requests. Who send these requests? Input output device. To whom? DMA controller. So DAC is the acknowledgement sent by the DMA controller to input output devices. So D0 to D7 you have to learn only 1 or 2 lines about all these pins. No need to attempt the entire paragraph. you have to just write that D0 to D7 is data bus line, and these are used to transfer the data, right? And in the next we can show input output I0R, means input output read. When it goes low, then it reads the data. When input output write, same clock means the clock supplied by the microprocessor to every component. Reset means when it goes high, it means all the registers being reset, means set to 0. What is chip select? An active low input which enables input output read or write input when 8257 is being read or programmed in the slave mode, means when it enable means when its value is 1, then it works in slave mode, and when its value is 0, it works in master mode, which I have told you before. So this is all about the block diagram of DMA, which you have done in CSA also. I have explained you each and every part. Still, if you are having any doubt, you can discuss that doubt in the group which we have formed, and you can ask any question there. Thank you so much.